Hello everyone, welcome to our channel OnlyPhysics JEE Grad. So in today's video we'll be discussing JEE Advanced PYQs from the chapter Optics. This will be the first video on this chapter and the topics will be covering our reflection of light. There will be a total of only 12 questions. In the second topic, in the same video, we'll be discussing refraction, spherical surfaces, and TIR. So there will be total of 41 questions from these topics. Only 6 will be covering today. Okay. So let us start with our first question. So let us start with our first question. Right. So in this question, we have a ray of light traveling in the direction this. So this is actually E cap, I cap, right? So it is 1 by 2 I cap plus root 3 j cap. Incident on a plane mirror, after reflection, it travels along the direction this. So this must be our reflected, the direction of reflected ray. So it is ER cap will be equals to 1 by 2 I cap minus root 3 j cap, right? Now we know, let's say this is our plane mirror, and if this is our incident, so if this is EI cap, and this will be our ER cap, right? And this is our normal. So we can make this vector like this. And if we take the dot product of these two, so we'll get EI dot product ER cap. So let's say this angle is theta. So this is the angle between both of them. So it will be EI magnitude into ER magnitude to cos theta. And we know these will be 1. So this is simply cos theta. If this is theta, this whole will be 180 minus theta, and we have to take half of these, right? So let's find them. So if we dot product that, we will get 1 by 4 minus 3 by 4. So that turns out to be cos theta will be minus 1 by 2. So theta will turn out to be 120 degrees, right? I mean, like you can write cos 120 as sine cos 90 plus 30, right? So it will be minus sine 30, right? So it will be minus 1 by, okay. So theta we get is 120 degree. So theta is 120, then 180 minus theta will be 60 degrees. And we need the angle of incidence. So angle of incidence will be 60 by 2, right? So it will be 30 degree, right? So this question is quite easy, of course. So which option is correct? The option A is right. Let us move on to our second question. So let us move on to our second question. So here, so in an experiment to determine the focal length f of concave mirror by UV method, a student places object pin A on a principal axis at a distance x from the pole. Okay, the student looks at the pin and its inverted image. So the image is actually real, right? Image is actually real. So the object must be between, either between F and C, or it should be between 2C, C and infinity. So for C we can also write it as 2F, right? So these two may be correct. From the distance, keeping eye line with the PA, okay? The student shift his eye or her eye, whatever, towards left. The image appears to the left, to the right of the pin. Okay, so this is actually question based on parallax, right? So let me teach you about this parallax a little bit. So what happens is, uh, how do we know if two objects, let's say this is A object and this is P object, and this is our eye, okay? So how we know that this A So how you know if this A and this B, the A is near to your eye and B is far away? How do you know? So we do this experiment. You can also do. So look, if let's say this A is here and B is here, you start to move your eye. If you see A is moving faster than B, if A is moving faster than B, then we can say A, if A is moving faster than B, that means A is closer to you than B. Okay, so this is what you call parallax. Okay, now what happens? Student shift his eye towards the left, right? The image appears to the right of the object beam. Means image. So if you are going, so let's say this is left and this is right, right? So A moves more towards the right than B. And this is exactly what is saying. The image appears to the right of the object beam. Okay, to the right of the object beam. So means this must be image and this must be object. Okay, and this is our concave mirror. So the situation is like this, right? And in what case we cut the real image, but the image is beyond object, right? So in which case it happens? It happens for the case between f and 2f, right? So which option is correct? Then x should be between f and 2. Okay. So for the 18th, B option is correct. Now let's move on. So this is quite interesting question. You should remember this parallax. Let's move on to the third question. So we have this. Oh, kids. So this question is actually simple. So we have to find the maximum number of reflections. So let's say this ray will move like this, right? And after this reflection, so when it reflect like the first time, how much it is covering? Let's say this is covering at distance x. So this angle will be 30 degree and this is d. So we can simply write tan 30 degree, right? So we can write tan 30 degree will be equals to x by d. So x will come out to be d tan 30. Okay, d is what? 0.2 and tan 30 will be 1 by root 3. So this is our x, right? So the first reflection, it is traveling a distance x. Now when it is about to do the second reflection, how much it will cover? So this actually it is covered. Now again x will it cover, right? So the total number of reflection will be according to the total number of x, right? So let's say there are n reflections and into x should be equals to this total distance, which is 2 root 3. So n will come out to be 2 root 3 divided by x, which is 0.2, and into root 3. So it will be 30, right? Yes, so there will be 30 reflections. Okay, we'll excluding this part. So this we don't consider it. Okay, otherwise we'll be marking 31 option. Okay, so again, quite an easy question. Uh, let's move on to question number fourth. So this is our fourth question. Okay, so this is incomplete. Let me add the second image of this question. Right. So what we have here, so a point source of light P is placed at a distance L in front of the center of the mirror of width D hung vertically on a wall. Okay. A man walks in front of the mirror along a line parallel to the mirror. So we have a mirror and it is hung up on the wall like this, and a man is moving parallel to the mirror. So a man is moving like this, okay, along a line parallel to the mirror at a distance 2L. Okay, let me. A point source B is placed at a distance L in front of the center of the mirror. So yes, so this is a source, and this distance is L, and this is actually the center. So if the mirror is of width D, so this must be D by 2, and this distance also must be D by 2. Okay, and the man is moving in a line parallel to the mirror at a distance 2L. So this total distance is 2L, right? From it is shown in the figure. Okay, so we don't have the figure. The greatest distance over which he can see the image of the light source in the mirror. Okay, so this is a quite simple question. Let's say this is the last ray which will hit the mirror on this extreme and it moves like this, right? So we have to make the field of view. Okay, uh, that is what question is asking actually. So this is the field of view where you can see this source in the mirror, right? So this is S dash. So this is quite simple, right? Let's make this diagram. So let's say this is theta, this will be 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 theta. Okay. So if you use this triangle A, B, C. So in triangle A, B, C, tan theta will be BC upon AB, right? So BC is D by 2 and AB is L. So it will come out to be D upon 2L. Now let's use this triangle. So let me write it C, and this is P, this is, let's say, Q. So in triangle PQC, so tan theta will be equals to, this is perpendicular. So let's say this is X, and similarly, let's say this is X, and this is actually D. So we'll just call it X. So it will be X upon this distance, 2L. Both are equal, so we'll get X upon 2L is equals to D by 2L. So we'll get X as D. So the total distance through which you can see the image of the source will be X plus D plus X. So it will be 3D. Okay. So B will be the option. Right? Let's move on to our fifth question. So let's move on to our fifth question. Right. Okay. So we have two questions here. Okay. So this is our fifth question. Now here there are three plane mirror form an equilateral triangle with each side of length L. Okay. There is a small hole at a distance L greater than 0 from one of the corner as shown in the figure. So we don't have the figure here, but let me make the diagram. So it's like this. So these are the three plane mirrors, and this is a hole. Okay, right? So all these three mirrors are of length capital L and at a distance L. So this is small l. Okay. Now what happens is a ray light pass through the hole at an angle theta. So this ray, let me change the fan. So this is the light ray. It is coming at an angle theta. Okay, this length is L. Now can only come out. So let me just make the diagram more clear for you guys. So it should be like this, right? So this angle is theta and this is L, right? Okay, can only come out through the same hole. Okay, so after reflections, there can be many reflections and it should come out of this right hole. The cross-section of the mirror configuration and the ray of light lie in the same plane, right? Which option is correct? So let's check the options because there can be infinite number of situations arises. Okay, so let's check A option. So the ray of light will come out for theta is equals to 30 degree 4012. So from 0 to L, you can take hole at anywhere, but it should come out for angle equals to 30 degree. So let's take this angle 30 degree. Now what happens is this ray of light will go like this, right? Right? Okay. Now let's check these angles. Now this angle, if this is theta, so this is 30, right? So this will be 30. And we know this is 60, so this must be 90, right? And if a ray of light coming at an surface at angle 90 degree, then it will reflect back. So it will move like this. Okay, so A option is correct. So for any L, it will always come out on this mirror at an angle. Come on this mirror at an angle 90 degree. So yes, so it will reverse back and will definitely come out from the same hole. So A is correct. There is an angle for L equals to capital L by 2 at which the ray of light will come out after two reflections. Let me make the diagram again. So if I take L equals to L by 2, so the hole is here, right? Now the ray will be like this. So for with any angle, let's say the ray is going like this, right? So if this angle is theta, so this will be theta, this will be 60 degree. So this angle will be 120 minus theta. Okay, perfect. Uh, Look, the situation, there is an angle, so we have to just check an angle. So with the symmetry, let's take theta as 60 degree. Okay, let's, I mean, this will become a symmetric situation. And with if you take theta equal to 60 degree, maybe this C option we can also check. Okay, so let's just take 60 degree. So if this is 60, this is 60, right? So if this is 60, then ray will be parallel to this surface, because if this is 60, then if you take 9, this will be perpendicular. So this will be 30, this will be 30, this will be 60. So it will be parallel. And if this is parallel, then it will definitely come out of this hole. So yes, for angle theta equals to 60 degree, this situation is valid, right? Now, let's look the C part. The ray of the light will never come out for theta equals to 60 degree and L equals to L by 3. Okay, so we have to make another situation. So this is our triangle, right? And we have a ray like this. Okay, right? Now let me rotate it a little bit. Now, this is our 90 degree, right? So this ray will go like this. Oh, okay, let me check. So let's write the situation first. So this is angle 30 degree, right? Oh, okay, so this is 60. So this is 60, then this will be 60. So this will be 60, and again this will be 60. So the ray will be parallel, right? So this ray will be parallel. So let me make this ray parallel like this. Okay. Okay, now look. So this is L by 3. So this will be 2L by 3, right? And if this is 2L by 3, this must be 2L by 3. And this is 2L by 3, then this will be L by 3. And if this is L by 3, then this must be L by 3. right? Because the angles are same, right? So this will be L by 3. Okay, no worries. So this will be 2L by 3. Now look, if this is 2L by 3, so this ray must go at this angle like this. Right? So this is 12 by 3. So now I'm putting it in green. So this will be 12 by 3. Right? So again reflection will happen and the ray will go like this. Okay. So this will become L by 3 because this is L by 3. So angle is always, it is always making an angle 60 degree, right? Now what will happen? This is L by 3, this is 12 by 3. So this ray will go like this. Okay. Due to this, this distance will become 2L by 3 and this will become L by 3. And if this is L by 3, then the last part will be like this. So the ray will come out from this same. Okay. So definitely with these situations, a ray will come out. So this is wrong. The ray of light will come out for theta equal to 60 degree definitely, and L between L by 2 and L, yes, it will come out after 6 reflection. Let's check. So this is the first, this is second, this is third, this is fourth, this is fifth, and after fifth it directly come out. So it's not the sixth reflection. So this is also wrong. Okay. So this question is quite interesting and it's a moderate level question, right? So you have to make the situation. Let's move on to our question number 6th. Okay, so a wire is bent to form a triangle like this. Mm, image. Okay, so this is again very easy question. So let's say this is A, this point is B, and this point is C. So for B, for B, U is minus F by 2. Okay, and F is, so if this is F, so we have to put as minus F. So let's find the image. We my plus 1 by minus F by 2 is equals to 1 by minus F. So 1 by V will be 2 by F minus 1 by F. So V will be 1 by F. Okay, so this is the image of P. So it will be here, right? At a distance F. So if this is F by 2, so image will be like here. So this is P dash. This distance is F, right? Now for the C, the image will be like here at infinity. This is C dash because it is at F. So C dash is like here. Okay, let me change the color. So this is B dash and this is C dash at infinity, right? Okay, and for A, we have to take the height of image. So this is height of object, let's say, and if this is F by 2, so height of object will be F by 2. So we know height of image upon height of object will be equals to will equal to minus F minus V by U. So height of image upon height of object, it is F by 2 because angle is 45 degree, right? So this is F by 2 minus. So V is plus F upon U. U is minus F by minus minus. This will get cancelled. So height of image will be F, right? So this two will go here and yes, so it will be F. So we will see the A will be like this. So this will be A dash, right? And image is like at infinity. So which is the correct? So this is the correct. D option is the correct. Okay. So don't worry about the left or right situation. So it's fine. So you don't have to worry about it. So D will be the option. Okay. Let's move on to our 7th question. So let's move on to our 7th question. Okay, again we have two questions. So this is 7, this is 8. Sorry. So a concave, okay, it's this image is like wrongly cropped. Okay, sorry for that. Now let me read the question for you guys. So in this question, we have a concave mirror is placed on a horizontal table. Okay, so this is a horizontal table with its axis vertically upward, directly vertically upward. So let me make the diagram. So look, we have a horizontal plate like this, a table like this, okay, and we have a mirror placed like this, okay, whose axis is vertically upward. So this is the axis like this. C is the center of curvature. So let's say this is a C. A point object is placed at C. So we have object like here, okay, in the same place. Also look at it. If the mirror, okay, so if object is here, image will be from here, of course. If the mirror is now filled with water, so let's fill it with water, the image will be okay. So this is quite easy. Just we have to do it like qualitatively, right? Okay. So look what happens when the rays goes like this. Where they will move, they will bend towards normal. Due to this, this will be the O dash for this mirror. And look, if the object is placed beyond C, so image will be between C and F, right? So image will be between C and F. So this will be, let's say, I dash, okay? And now if these rays which are converging like this, okay? So at this point, what happens? They will move away from the normal. So like this. So they will hit like here, okay? At this point maybe between C and O, or maybe between like F and O, we don't know, but it will be definitely will between C and O, okay? So this final image, this eye, it may be between C and F or F and O, but it will definitely will between C and this point. Okay, so so this is, it is saying it is O. So let's say this is our C. So it will be between C and O. Okay, are you getting me? So and how the image will be? So image, so final rays are actually intersecting. Final rays are actually intersecting. Okay, so the image is real and it will be between C and O. So which option is correct? So D will be the correct. Okay, so this is quite easy, right? Let's move on to our eighth question. So we have a short linear object lies B along the axis of a concave mirror at a distance u from a pole. The size of image is approximately equal to. So look, this is our mirror and we have object lying along this like this. So this distance is B. It's very short, right? So it's very short and it is at a distance u. The focus is F. Okay, so the size of image, let's say the image will be like this. So we have to use longitudinal magnification formula for longitudinal magnification. So it is length of image upon length of object will be equals to minus v square by u square, right? So let's first find v. So look, all are variables, so you don't have to put the sign of anything. Let's just solve this. Okay. So 1 by v plus 1 by u equals to 1 by f. So we'll get 1 by v will be 1 by f minus 1 by u. So we will get v as uf upon u minus f. You should also remember this formula. Okay, so let's just put all those values here. Okay, so length of image will be equals to length of object into minus u square by f square upon u minus f the whole square divided by u square. So u square will get cancelled. So length of image will be minus b into f by u minus f to the whole square. So this will be the answer. Minus shows that if the object is like this towards this, then image will be like this. So they will be in opposite, right? So let's say this is the head of the yeah, or we can say tail of the object, and this is the head of the object, right? So this will be the head of the image, and this will be the uh, so this will be the head of the image here, and tail of the object tail of the image will be here like this. Okay, so negative signs just shows that they will be in opposite orientation. That's all. Okay, so there was options, many options, so it will be b into f upon u minus f whole square. Okay, so again, quite interesting question, but easy, right? So this formula is only valid when the object is small. So look, the short linear object is given, so it's fine. Let's move on to our question number 9th. Let's move on to question number 9th, right? Sorry. So we have an object and a concave mirror. Focus this. Both move along the principal axis of the mirror with a constant speed. Okay. So let's see, this is our mirror, and we have object here. Object moves with a speed 15 centimeter per second. So let's just say it's ux. Okay. So ux is this. And this will be positive because this direction we take as positive and this direction we take as negative. When the object u is at 30 centimeter, the speed of mirror is Vm. So we don't know about we don't have any information about Vm, but it is given the image is at instantly rest with respect to laboratory field. Okay, perfect. So let's first find V, or let's just use the mirror formula. So we have 1 by V plus 1 by U is equals to 1 by F, right? So if you differentiate it, we'll get minus 1 by V square dV by dt minus 1 by U square du by dt is equals to 0. And look, this is speed of image with respect to mirror. Okay, because all the distance we take is with respect to pole. So pole is actually the, you can say like pole is on the mirror, right? So all the distances we take from the mirror. So again, this is the speed of object with respect to mirror again. Okay, so definitely we need V. So let's just put those values. So 1 by V minus 1 by 30 will be equals to minus 1 by 10 because focus is 10. So 1 by V will be 1 by 30 minus 1 by 10. So this will be 30 minus 1, 3. So V will be equals to minus 15 centimeter. Okay. So let's just put all those values here. So we have minus 1 by V square. And look, this is the image of speed with respect to mirror. Okay. So we will write it here as V image minus V mirror. Okay. Minus 1 by U square. This is speed of object with respect to mirror. So again, we'll write VO minus VM is equals to 0. So let's just say this is UO or VO. VO is fine. Sorry. Now, let's put those values. So look, Vi is 0 and this is minus 1 by 15 square, and this will be plus. So Vm, right? Minus 1 by U. U was 30, so this will be 30 square. VO. VO was plus 15 centimeters. So everything is centimeters, so we'll get the answer in centimeter again. Minus Vm is equals to 0, right? So let's just uh, make it here. So Vm will be equal to, so this will get cancelled and we'll get 4, 15 minus Vm. Okay, so this will be 4 Vm is equals to 15 minus Vm. So we will get 5 Vm is equals to 15. So Vm will be plus 3 centimeter per second. Okay, so this mirror must be going like this with a speed 3 centimeter per second, right? So again, quite easy question, but the concept is very nice, right? So let's move on to question number 10. So let's move on to question number 10. Okay, so this is 10th, 11th, and 12th. Okay, so last three questions from this topic. Now, we have a image. Okay, so maybe again this question cut here. So this is convex mirror. Okay, this is a convex mirror of radius 20 centimeter. So we have R as plus 20 centimeter, and the along its, so this is the image. So image of an object approaching a convex mirror of a curvature this is observed to move from this to this. So V initial we say 25 by 3 meter, and V final we can say 50 by 7 meter, and the time it takes is 30 seconds. What is the speed of object in kilometer per hour? So this is quite easy. So with this information we can find UI, and with this information we can find UF, right? So let's just use the mirror formula. So 1 by V plus 1 by U is equals to 1 by F, right? So it will be 3 by 25 plus 1 by U is equals to, so F will be 10. This will be 10. So we'll get 1 by U will be 1 by 10 minus 3 by 25. So the LCM will be 50, right? So this will be 5 minus 6. So U will be minus 50 centimeter, 50 meter, right? So this is U initial. Now let's find the U final. It will be again 1 by 10 minus, I'm just directly putting those values. So LCM will be 55 minus 7. This is U final. So U final will be 50 by 2. So it will be minus 25 meter, right? Now object moved from 50 to 25. So right, so we can say delta U by delta T will be 25 divided by in 30 seconds. So this will be meter per second. And if you want to convert it into kilometer per hour, so it will be 18 by 5 kilometer per hour, right? So this will be 5, this will be 6, and this will be 3. So it will be 3 kilometer per hour. Okay. So again, quite easy question. Let's move on to question number 11th. So we have a statement. The formula connecting UVF for the spherical mirror is valid only for mirrors whose sizes are very small compared to the radius of curvature, right? Why? To correct spherical aberration, right? To correct spherical aberrations. Okay, because you see, actually this formula they are not valid for spheres, right? Because spheres don't have actually don't have focus. Okay, so if you take very small mirror, or you can say the aperture of the mirror is very small, then they will be compared to parabolic mirrors, right? Hence, they will have a focus, and those formula will be valid, right? So this statement is correct. Now, for the statement 2, law of reflection are strictly valid for the plane mirrors, but not for large spherical mirrors. This is wrong. Law of reflection is valid for all types of mirrors, so this is wrong, right? So C will be the option, right? Sorry, I have a cough a little bit, so you have to manage. Sorry for that. So C option is correct. Let's move on to our last question from this topic. Then we'll move on to our second topic. So we have a thin rod of length, this, and is placed along optical axis in front of a concave mirror. So, so we have a concave mirror like this, and a rod is placed like this, right? Whose length is f by 3. Now it is saying its image is real and elongated, okay, and it just touches the rod. So if it is real, then image must be here, right here somewhere. And if it is just touching, so situation must be like this, just touching. So I mean this point must be at C, right? Perfect. So C means this is 2f. So this distance is actually 2f, right? Because this is actually center of curvature. Okay, so if this is 2f, then this distance will be 2f minus f by 3. So it will be 5f by 3. So this, let's say this is A, this is B. So B is here, then B dash will be here, and A dash will be here. So let's find A dash. Okay, so we have UA is minus 5f by 3. Focus is minus f, of course, right? So let's just use the formula. 1 by V plus 3 by minus 5f equals to 1 by minus f. So 1 by V will be equals to 3 by 5f minus 1 by f. So 5f will be LCM 3 minus 5, 1 by VA. So A dash will be, so VA dash will be minus 5f by 2. Okay, so this distance is actually minus 2.5f. So this distance will be 0.5f. Okay. So the magnification, of course, it is asking about longitudinal magnification. So we'll write length of image upon length of object. So length of image is actually 0.5 f upon f by 3. So f by 3, f will get cancelled. So we'll have 0.5 into 3, which is 1.5. And of course, it will be negative, right? Again, the same situation. If this object is like this, right? And then this object will be like this. So it will be negative. So this will be longitudinal magnification minus 1.5, right? So it is just asking magnification. So we will not write negative. We'll just put 1.5 in the answer. Okay. So these were our 12 questions. Let's move on to last 6 question of this video, right? So let's start with our first question. So we have a point source S is placed at the bottom of a transparent block of height this and medium is this. So the shaded region had a medium 2.72. It is immersed in a lower refractive index. Let's say this has mu. So diameter. So this situation is like this, right? So if we have object like this, it will move like this, right? So this is R, this is H. We know the formula, right? So we know the formula for R. It is H upon under root mu square minus 1. So mu is, let's say this is mu1, so this is mu2. So mu is actually mu1 by mu2, denser on rarer, right? So let's just put those values here. Okay, so R we have to put 11.54 divided by 2 is equals to H. H is 10. So everything is in millimeter. Mu will be mu1. So mu1 is 2.72. Let's say this is mu which we need to find on this is square minus 1. Okay, so this will be 5.57. So we have 0.577. And let's just square both sides. This will be 1 upon 2.72 by mu whole square minus 1. So if you solve this, you will get 2.72 up by mu whole square and minus 1. This will be plus 1. So 1 upon 0.0577 square. Okay. So let me use the calculator really fast. So 1 divided by 0.577 and again 0.577. So this is approximately 3 and plus 1. So this is 4. So 2.72 divided by mu to the whole square. Okay. So we will have 2.72 divided by mu equals to 2. So this will be mu will be equals to 2.72 by 2. So this will be 1.36. Right? So again, quite easy question. Let's move on to the second question. Okay. So this is our second. This is our third. So the second question, a ball dropped from a height 20 meter above the surface of water. So this is water. This is a height 20 meter. And this is our object, right? Refractive index of water is given 4 by 3. A fish in the lake. So we have a fish here, right? In a line, pole is looking at the ball at an instant. The ball is 12.8 meter above the water. So look, this is our ball. It is at a distance 12.8 meter, right? The fish sees the speed of the ball. Okay, so let's say this is x. So so we'll use mu2 by x v, right? So this fish may see the object to be here, right? So this will be our image, right? So we'll remove this. So this is our object right now at this situation, okay? And the fish will see it here. So it will see here, right? Let's say this is y. So we will use this formula. Of course, we know how much y will be. Y will be equal to mu into x, but let's just derive it. So mu2 by y minus mu1 by x will be equals to 0 because r is infinity for uh, plane surface, right? So mu2. So this is our mu2. This is our mu1. And this mu1 is 1, mu2 is 4 by 3, right? So if you put values here, so you will get 4 by 3 y is equals to 1 upon x. So simply x will be or y will be 4 by 3x, right? And if you differentiate both sides, you will get dy by dt will be equals to 4 by 3 dx by dt, right? This is velocity of image is equals to 4 by 3 velocity of object, right? Now, there may be a question you will get that let's differentiate here. Okay, now if you differentiate here, you will get mu2 by y square, right? Like this dy by dt minus mu1 by x square. So this will be plus dx by dt is equals to 0. So this is actually wrong. Why? As it is already 0. So differentiate of 0 is will be 0. Okay, so this is a wrong concept. You just equate it and then differentiate it, right? If there was any constant here, then you should differentiate it, right? But as it is 0 already, you don't have to differentiate it again. Okay, you just equate then differentiate it. So we need to find the object. So how will you find? We'll use the kinematics, right? The third equation. So we'll have v square equals to u square plus 2as. V square will be, this is 0, 2 into 10. The S is what? Displacement. So displacement is actually 20 minus 12.8. So it will be 7.2. So here V will be 12 meter per second. Okay. So just put those values here. So we'll get 4 by 3 into 12. So answer will be 16 meter per second. If you use this, you will get 21.33, which is wrong. Okay. So be careful. Sorry. Let's move on to question number 3. Right. So a light beam is traveling from region 1 to region 4. Okay, like this. And the angle of incidence theta for which the beam just misses the entering the region 4. Okay. So here light must go like this. Okay. So let's use the Snell's law for this boundary, this boundary, this boundary. And look, if you divide them, then the answer will be just region 1 compared with region 4. So we'll use like that. So mu of 1 sine theta must be equals to mu of region 4 sine 90, right? So let's put the values. N naught sine theta will be equals to n naught by 8 into 1. So sine theta will be 1 by 8. So theta will be sine inverse 1 by 8. Okay, so B will be the option. Right? So this is quite easy. So 68 was 16, right? 68 was 16. Okay, this is wrong. So again, this question is quite easy. Let's move on to question number 4. Question number 4 we have here. Right. So this is quite an interesting question we have. Okay. So there is an object which is at the bottom of this. Now what happens? Light move like this, right? So light move like this. Let me show you. So light move like this. Okay. Then there will be refraction. So it will move like this, right? Then what happens? Due to this refraction, image will form. So image, now look, image can form here, right? Here or here after reflecting from this, right? And then the refraction will happen again and then image will form here. So first we'll have to check where the image will form after the reflection. Okay, look, this is the final image. So this is our final image. This is our final image, and this was the object. So this was the object. Okay, now look, if A is the image after reflection from this mirror, if A is the image, then what will happen? So these ray will go like this. So let me show you. So these ray, uh, let me show you the black, okay, black pen. So these ray will go like this, right? And after refracting at this surface, they will move like this, right? Due to this, what will happen? The image will be here, not here. So the A point is wrong. Are you getting me? So image will be like this. So A point should not be the image after reflection from the surface. Let's check B. The for the B case, B is again similar. If, ray goes like this, they will bend towards normal, and again image will form here. The final image will be here, not here. So again at B, image won't be. So the image should not be at B after the reflection from the mirror, right? So only the C point will left. Why? Look now, I'm clearing this all part here, clearing these parts. Now let me show you. Look, if here is the image forming, that means the rays must be coming towards this point, right? So rays must be coming towards this point. If these rays are coming towards this point, then they will bend towards the normal. Okay, so let's make the normal here. So this is normal, so they must bend towards the normal. So if they bend toward the normal, what will happen? They will move like this, right? And hence the image will form here. Okay, so actually after reflection, the image should form here. Okay, are you getting me? So let's use all those things. So just clearing all these part. So I'm just putting the image one, image three. Okay, so there may be many. So with this object, let's say this is our image one after refraction. So image one is after refraction. Okay, then the image two will be here, right? So image two is after reflection from the boundary, and image 3 will be our the final image. This is I3 is our final image. Okay, perfect. So let's just start using our formulas now. Now look, the object is here, and after refraction image will form here. So we can find this I1. So this, let's say this distance is our x1. So this distance is our x1. So x1 will be simple. It will be the object distance, which is 33.25 divided by 4 by 3, right? Which is u upon mu, right? So if you calculate 33.25 divided by 1.33, so you will exactly get 25. So this x1 is our 25, right? And what is happening is actually the I1 merges with I. Okay, so let's just put it here. So this will be our I1. Okay, actually quite nice. Now this I1 is actually object for this mirror. So for you, it will be minus 40 centimeter. Are you getting me? And let's say F is like this and V is here. So V is here. And let's just say this is our X2. Okay. So V will be X2 plus 15. Are you getting me? So V will be X2 plus 15. Okay. V will be our X2 plus 15. So let's just find V first. So look, V will be X2 plus 15, right? And look, So let's find v first. So we'll use 1 by v plus 1 by u is equals to 1 by f. Right. Okay. Okay, perfect. Now, look, if I put these values here and then I have to find x1, it will be a bit complicated. So let's find this x2 first. Okay, let's find this x2 first. Now, look, this is x2 and this is x1. We know x1, right? So how much x1 will be? So look, if rays goes like this and image is forming here, right? So x2 must be equals to 25 by 4 root 3. Are you getting me? Okay, so x2 will be equals to 25 by 4 root 3, right? Okay, so if let's put it here. So we will be 25 by 4 root 3 plus 15. Now we have u, and we can get our f, right? Okay, remember for this image will be in this side, so we have to take it as a minus sign with a minus sign. Okay, so let me calculate the v first. So it will be 25 divided by 4 and multiply by 3, right? So it will be 18.75 plus 15. So we will get minus 33.75. Okay, so let's find f. So we'll get 1 by f will be equals to minus 1 by 40 minus 1 by 33.75. So if I use the calculator really fast, 1 by 40 will be 0.025 minus, this will be minus, of course. Okay, so 1 by f will be equals to minus 0.025 minus 1 divided by 33.75. So it will be minus 0.03 approx. Okay, so 1 by f will be equals to minus 0.055. So focus will be opposite of this, so it will be 1 upon 0.055. So it will be minus 18.18 centimeter. Okay, so this I have taken approximately, but it was not like this. So option will be C. Okay, negative 18.33. Oh. Right? So this question is quite interesting, right? Like you could have find first equation in V and then solve for that, but we have done in the reverse order. We have first find x2 by using this formula, u by mu, right? So this was u by mu. So we get the v. So if we get x2, we can find v. So we have v, we have u, and then we use the mirror formula. Okay. So situation is very simple, a bit complicated, but this question is quite easy. Okay. You must have solved these question in your preparations. Let's move on to last two questions, fifth and sixth. So we have these two questions. Now, a point object is placed at the center of a glass sphere. So it was glass sphere of radius 6 centimeter. So we have a sphere, okay, and object is placed at the center. Okay, this is our object. Refractive index is 1.5, the distance of virtual image from the sphere. Okay, so look, we don't have to actually solve it. If there is any ray which falling on this, they will be normal to the surface, right? So they will move like this, and hence image will be at here only. Okay, so 6 centimeter will be the answer. The distance of virtual image from the surface will be 6. Yeah. Okay, so there is nothing to do in this question. Quite nice, right? A source emit a frequency 600 hertz inside water. The frequency heard in the air will be equal to. Look, the frequency is source dependent, right? So only wavelength and what? So look, only wavelength, right? Let me write it. So only wavelength and speed of wave changes during refraction, right? Frequency remains constant. Okay, so 600, this option was 600 actually. So C will be the option, right? So nothing we have to do in this question also. So these were the 6 questions which we have discussed today. Uh, there were left, I think, uh, 18 or 17, I think. Like these questions we'll be discussing in next videos. Okay. So let's finish this session. Thank you.